Thank you all for joining us today. So I'll be presenting on the GrowZone Tracker.com. It's a new website. It's a mobile website as well. It's not an actual inherent app that you can get from the Apple or Android store. So you just use it as a mobile website. It is part of e-GRO, but it does have its own URL. So if you just go to GrowZoneTracker.com, you'll be able to see the app that we're talking about today. And you can make it an icon the same way that Brian has showed you on either an Android or an Apple by using those iPhone features or Android features so that it can be quickly. Once you do that, it will look and feel like an app because it's been formatted for a mobile device. However, it is a mobile website, and that makes us be able to keep it up to date easier in the long run. This was a joint venture. Sarah White from Clemson University, who's a panelist today and will be able to answer some questions if we have them on water quality. Dr. Whipker handled the floriculture along with Dr. Brian Krug, who is now at Pioneer. And we use Torx Media to develop this. They currently work with a lot of our growers here in Virginia, and we thought they would be, they were a great team to do this. This was made possible by the Horticultural Research Institute and the American Floral Endowment. They funded the majority of this project and made it possible for us to do it over, it took us about 1.5 years to build out. So why a mobile website or app for GrowZone Tracker? So as an extension agent, I answer many questions about pH and EC, but we typically use them to look at a problem. We put it on a Post-it note, it gets lost in our files, or that Post-it note just gets lost altogether and we don't know what that reading was previously. So we don't really have a great way of having data throughout time at many locations. So we were thinking that it would just be a simpler function to be able to both timestamp and geolocate using a map feature where you recorded that data on the go at the nursery. And then you could view it both on your computer in your office, or you could view it on your phone as you travel around the nursery or greenhouse that we work in. So why pour through and water quality? I'm the nursery specialist for Virginia Tech, and so I helped write the best management practices. And nutrient management, our goal is to apply fertilizers at the recommended rates, but to know if those fertilizers are doing what they're supposed to, if we're getting our money's worth, and if we're having any other issues associated with the fertilizer, it requires regular monitoring. And this ties in with irrigation management, that we want to apply adequate and uniform application of quality water. So we'll also be able to see how our water quality is affecting our plant health, soil, substrate, chemical properties by doing these pour-through methods. So nutrient management, one of the big things we want to focus on is pH. It's very important on floriculture crops as well as nursery crops, with varying taxa having specific needs. But the main reason that we really want to focus on pH is we want to make sure that our nutrients remain available throughout the production period. This is what nutrient availability looks like over a pH range of 4 to 8. And so we usually want to be between 5.5 and 6.5, 6.2 to make sure that we have all the nutrients that we need, especially those micronutrients that may become less abundant if we go low, and calcium, magnesium, if we go too high, may become overly available. EC, in the nursery industry, it's quite simple, but in the floriculture industry, and why we enlisted the help of Drs. Krug and Whipker, is that you have tons of ranges that you grow different crops in, ranging from 7.6 EC and millisiemens per centimeter up to 3.5. So you have those light and heavy feeders that you need to be on top of and monitoring, especially when you're growing in weeks, not months, like us in the nursery industry. So the way we do nutrition and pH monitoring is we typically use a pour-through method. There is an extraction for larger containers that can be used. The pour-through method is where you add water to a container and displace water after an irrigation. And so you get a sampling of what is that pour water look like that reflects your nutrient and pH your salt levels and your pH levels in those containers. In nursery crops, we can even do one other step and do a tip method where after 30 to 45 minutes after an irrigation, we may not even have to place water in that container. You can actually tip the container and get enough sample out to be able to measure pH and EC using a probe like you see in the middle. A combination probe from Hanna Instruments, or now there's many other companies that are putting them out, is a quick and easy way, $200 instrument that gives you a ton of information with a little bit of monitoring time. For the nursery industry, probably the best publication out there was done by Anthony Labude. He has the pour-through extraction procedure. If you put pour-through and Labude or NC State, this is what you'll get at and it's also available at the Nursery Crop Science Info website. And it goes through the 10 steps to how to conduct a pour-through, tells you how much you should be pouring on a given container, and then how to interpret the results, and if you're using different units, how to convert those units. So to make sense of this data for us and to create a matrix, decision matrices for you, which is one of the things we wanted to include in our mobile website, we created these tables with much argument between all four of us. But we have substrate EC categories on the left, and on the top we have substrate pH categories. So for instance, camellia is a low feeder that would like a low pH, what you see in the upper left quadrant of the plants. Whereas hydrangea macrophylla, if you want to do a pink flower, you're going to grow it at a high nutrient level or high EC level and grow it at a high pH, versus the blue macrophylla, which you'd be growing at the low pH to ensure aluminum availability. We've also included in these tables, based on Dr. Whipker's work, conversion rates. If you don't use the pour-through method and you prefer an SME, saturated media extract, or the 1-to-2 extract method, there are some guidelines for how you would interpret that data. For the greenhouse, the best publication out there probably is Dr. Whipker's Monitoring and Managing pH and EC Using Pour-Through Extraction Method. This is available through the Floriculture, NC State Floriculture website. It too has the step-by-step guide of how to do pour-throughs in both small containers and cell packs, so that you can get the data that you need to input into the system. We also created the same matrices for annuals with EC categories and pH categories, and then again for perennials. And we tried to be very specific. The one thing I'll point out on this slide is that if you look at salvia, which is in the first two columns of the substrate pH categories, it ranges widely on the species, and in some there was not even always agreement. These were the initial tables that we used. We give you some more refinement when you're choosing your pH. However, we tried to be very conscious about the different production of different species at that level, and sometimes we were only able to go to the genus species where there was no need to go beyond that. So why do we want to do this? We would like to measure both our pH and electroconductivity over time. So basically this is for nursery crops. This would be in weeks for floriculturalists, but this is January to December. So I want to know what happens to my CRF if I pot up in January. I want to know that it turns on, it releases as I want, and it turns off in December, or as we go into the fall, so that we harden those plants off and we also get our money's worth. I'm also looking for any possible dumps that may occur if there was a fertilizer issue, or if there was an environmental issue that occurred that may trigger fertilizer to release. Concurrently, while we're doing this, we're also monitoring pH, which is shown as the dark line at the top, dark dots at the top of this figure, with the y-axis being now on the right. And so we're tracking that pH, seeing it dip as the salts increase, and tracking that throughout the production period. This lets you know how your lime's doing. Are you using a coarse or fine lime in the case of nursery production, and are you getting the longevity you need to last that crop out and make it to the retail center? The reason we want to track it over time and not at a single point is if we would just take, I'm not sure you all can see my mouse, but if you look at just one point, let's say above April, that really does not give you much information. Though you may be optimal for your EC at that time, you don't know how your fertilizer's tracking, and you may not see instances where you need to do a flush or liquid feed to address low salt issues so that you make your target production date. So it really is good to track. Weekly's great, monthly's good. Basically, anytime you can track it over time and put the data in something that you can do, that is going to help you understand better how your control release fertilizer or your liquid fertilizer program in floriculture is working. So we can kind of put standard guidelines in, and we know we want to stay for electrical conductivity between that 2 and 0.5, whereas pH we want to be up there between 5 and 6-ish. And so we can see if we're staying in our guidelines, and that's what our tables that I showed you previously are supposed to do. The other piece of the puzzle here was, while we're building this app, we see many other options, and I would love to hear what you would think that we should include in this app in the future. But at this time, we wanted to include water quality for sure. It's something that you should be tracking to make sense of your pour-through data, and it's a low-hanging fruit in your nursery or greenhouse that can inform you much about some of the management decisions you need to do about nutrition especially. So water quality sampling, we have a how-to guide I'll show you in a minute about how you should water sample, but you should try to sample close to your intake depth and not near the shore where you see the algae building up in the left bottom corner of this slide. So you want to dip a bottle upside down, push it under the water to a given depth, and then flip it. At the surface, there's just too much biological and chemical reactions going on constantly to get a good read for what's going on. You could also just do it in your pump house, and that would be meaningful, or do it at an irrigation head. All three of those tell you a little bit of different things, but are all useful. As far as what the container is seeing, probably at the irrigation head is the best. If you want to know water treatment, then your pond and your pump house is best. So we had to come up with guidelines, and these were put together by Sarah, and we kind of all worked to vet them. And so we created water quality for non-saline waters, for pH, conductivity, alkalinity, and DOC. And so we have what they should be for the pump and pond, as well as for the nozzle, which is shown on the right. And so all of this should be as what we are using for our guidelines that I'll get into, that the app will show you if it's good, bad, or ugly. So first of all, what can water quality tell us? Well, first we can look at our bicarbonate and alkalinity. I'm sure everyone knows that it's not pH that we're worried about, it's alkalinity that we're worried about in affecting our treatment efficacy of chlorine, and also having a high pH. pH alone is not bad. High alkalinity coupled with high pH is the problem. But on the other side, it's also liming for you. So you may be liming some using your alkalinity, and that's what's helping keep your pH up. And how much do I need to acidify your water? You can use these values to inform you when you want to lower your pH of your irrigation water. Do you need to better monitor your salts levels? Is your pond getting hotter in the spring? Is it getting more salt concentrations because you're having a micro drought where you're not getting dilution? And how does this relate to your overall salt load? They may not all be nutrients, but those salts can create finally an osmoticum that could potentially create a drought-like stress condition in your plants, even though they're well watered. If we look at the complete water analysis at the pump, pond, or nozzle, we can look across all of these nutrients to make some decisions. Do you need to use dolomite or lime? Do you have enough calcium and magnesium in your water source? And if you have enough magnesium, then you might just need want lime to adjust your pH. If you're short on magnesium, you may use dolomite to make sure you have enough, and you may choose a coarser dolomite coupled with a fine dolomite for pH adjustment to make sure you're supplying those nutrients and buffering that nutrient capacity throughout the process. How much do you indirectly fertigate through the spring? Are you applying nitrogen in the form of ammonium and nitrate or phosphate and potassium on a regular basis? And if so, can you cut back on your liquid feed program because it's in your reservoir, your recycled water, and you're getting what you need from that. Do you need a micronutrient package if you're using well water? I know lots of places I've worked in my career, iron is usually very abundant in well systems, sometimes problematic. So do you need to add a micronutrient package, or do you have most of those micronutrients you need? And lots of analytical labs now, when they give you these reports that you're going to use to put into our system, they are actually going to give you pounds per acre of these nutrients, not just in the parts per million values we used, and that will let you make some other decisions. So that was kind of my spiel about why you should use this and the history of how we got here. I'll now go into the GrowZone Tracker and make sure we stick on schedule. So this is the login screen for the GrowZone Tracker. And so your first screen, you add a new user account. So you get to choose your user role. Are you a user and an admin? And if you're the admin, then you get to invite other people at the nursery that you'll later get to share this information with. Include your email. It's a password protected. Only me, Brian, Sarah, and we are the only ones that have the access to the data. So you list that in, and it's password protected. The first screen you'll see is the GrowZone Tracker, where you have dashboard, location, sampling sites, and I'll go through each of these in a menu up in the right corner so you can get back to any of these at any time. So we register our new company. Sorry. And there's also those facts I was speaking about early. So if you don't know for sure how to collect a pond water sample, under the FAQs that are shown, let me go back, and about halfway down the menu items, you have the FAQs, and those will be able to frequently ask questions, and we have them listed, and if you hit show on these, they'll show up and tell you how to do each one of these things, as well as show conversions for EC values or conversions for water quality units. And finally, at the very bottom, we have additional readings on the procedures and some of the extension publications we referenced to make this be able to inform us while we're designing this. Go back to the dashboard screen. So the first thing to do is to add a location. So your location is actually the nursery or the greenhouse, the entire property, not the bed of interest. But some of you may have different actual locations, nurseries or greenhouses located miles apart. Sorry, someone is trying to extremely get a hold of me on my phone. So we put in all of our information. You put in your time zone. This is important because you're going to timestamp your information so that you actually know the time of the day of recording. In pond management, this can actually make a difference because you have diurnal flux, and also it can make a difference sometimes in pour-throughs if you're collecting at. Actually, I was incorrect. I'm sorry, I got thrown off. Next, you want to add a sampling site. This is within a location. So this is choosing a bed. So your sampling site name may be bed A or zone 26. You can put the crop name in for your own reference, so when you're sharing with your colleagues, the container size, when the crop started. You can continue to scroll down in this and choose what crop type you want, and you're going to get an option of woody, perennial, or annual. And under those, once you select those, it's going to then restrain your desired pH ranges to the tables I showed you previously. So for this woody crop, we want 5.3 to 6.3, or the desired EC range of 0.8 to 1.2 in millisiemens per centimeters. And then there's room for any notes. This is just an outlook. Like I told you before, we wanted at the conclusion of all of our kind of internal discussion, we wanted to make sure that we had these tables available to you, that where you hit the question mark and it shows what we believe the substrate pH categories are for multiple taxa. However, we wanted to make sure you as the user had a very large selection of choices because you probably know best at what you want. So we provided broad range and narrow ranges, both for annuals and perennials. So you can fine tune that to know if you're in where you want to be with your pH and EC. To add water readings, to add a reading, so we've set it up, we've set our restraints on what we want for our different mineral, for our pH and EC, for our crop type. Now we can begin to start adding readings. So it's simply using the blue dot, the plus water, or the green dot, the plus plant. You click on one of those. So we're going to add a plant reading first, and we have our pH meter out in the field, and we take our reading and we enter the data. And immediately it shows us a color as we enter that data. So for pH, it's 5.4. That means it's green. That was the range that we had set for ourselves, but the conductivity is 0.4 and we wanted to be up more around 0.8. So that's outside of our range and shows up as red. So it's an immediate indicator if the ranges that you're looking for are within your set points that you want, and you can glance at a glance. For adding water readings, you get to go one step further. It's very similar. You're going to select the source, pond, pump, or nozzle, so that you can recall where that was selected. These standards are set by the water quality standards I shared with you, and are set. There is no changing them. They're based on the best management practices in floriculture and nursery. So pH of 8, a little bit high, conductivity 0.5, and alkalinity is 1.9. So I know I have an alkalinity issue that's increasing pH, and I may want to address that. It may only be occurring in the summer, but I may want to watch that and make a decision to do that. The other nice thing that we added is that you can also look at, you can edit the time and date of your stamps. So as soon as you hit save on these, the save on any of these readings that you're inputting, it records where you are and it records when you took that. However, sometimes you may want to go back and be able to adjust the data or enter data that you didn't have the app with you. So this allows you the ability to go back in time and enter data as you see fit. If we scroll down, you can enter the full analysis. Most likely suggest this in the office using the mobile website, not the app on your app icon on your mobile device. This, you'd be using a water quality report that you sent off to a lab and enter this data, and it will also show up in varying colors as you put this data in if you're in or outside of these ranges. Then we can go back to our dashboard, and this is where we add readings, and below it we have recent readings for given locations, and so it shows us that we have the plant, and it's a quick icon showing us the date through the different season or throughout the year. In icons, with the circle OK being that you're within the range, the diamond being showing us low, and that could also have an H in it saying that we're marginally low or marginally high. And then lastly, we have a stop sign saying that this is an issue and it needs to be addressed. And it could also have an L or H in it saying that it's low or high above your boundary condition. If we scroll down, you can also pull up charts. The dates here are construed together. We have fixed that problem in the app, but this will plot your data, showing you these bands of what margins you've set to see how you're doing and how it's performing over time over the course of the production period for pH and EC. And finally, if you want to check and make sure you're in the right location, you do have a site map at the bottom showing the bed that you are currently reading. So this is just showing, again, being able to add a sampling site where we're at the nursery. It's giving me the last readings information, but here I can also add a plant reading, add a water reading, view the site, or edit the site. And most importantly here, you can mark a site as complete. When you finish that crop, we thought it would be advantageous to be able to start a new crop so you don't have continuous data. And you can also go back and compare the data to previous years. The data that you do have can be downloaded to an Excel sheet as well. And so this is kind of just an overview of the functions where we have added the plant readings. It gives us the pH and conductivity. with instantaneous, adding water readings in the center, and then the ability to do basic analysis and have those OKs and you can see at the bottom with the full analysis, you're now starting to get those indicators if it's okay or not. I'd also just like to mention that we have a companion resource out there that kind of describes what we talked about today and provides our values that we used to make our decisions. And that is available at VT, at Virginia Tech's VCE, and the URL is at the bottom. It's only a 4-page, but it gives you the figures that we use to make these decisions. And then finally, I'd like to again thank our sponsors, Horticulture Research Institute, the American Floral Endowment, the Virginia Ag Experiment Station, and VCE, Virginia Cooperative Extension. And thanks to all of my, this was only made possible by Whipker and Drs. White, Whipker, and Krug working diligently with me to get this done. This also was an output of the Clean Water 3 grant, which Sarah White is the current lead, in which we're trying to reduce, remediate water. And we're in our 3rd year of that project, and this is one of our outputs. If I could have any questions, that would be great.